hello. Welcome, welcome, welcome. Welcome in, welcome in. What's up, guys? Have a seat, have a seat. How's your week going? Happy Tuesday. So the theme or like the goal of this week is to really hone in on the heaps data structure. So today we're just going to focus on that. I'm going to try attempt on a new heaps problem. So going to try to see if what I learned from yesterday stayed in my brain. You feel me? Okay, so let's see, where are heaps? Heaps. Okay, I'm going to do easy. Let's see. Yeah, let's try high five. What the fuck? What about this one? Last stone weight. So we'll read the problem and see where we can use the heap. Why is heaps is useful in this problem. So you're given an array of integers, stones, where stones I is the weight of the ith stone. We're playing a game with the stones. On each turn, we choose heaviest 2 stones and smash them together. Suppose the heaviest stone have weights x and y, with x less than equals to y. The result of smash is if x equals to y, both stones are destroyed, and if x is not equals, the stone of weight x is destroyed and the stone of y has a new weight. So we just reduce down from a smaller one. At the end of the game, there's at most 1 stone left. Isn't the weight of the last remaining stone? If there are no stones left, return 0. Okay. So we'll get stones, for example, it's 274181. Okay. Each turn we choose the heaviest 2 stones. Oh, we're choosing the heaviest 2. Wow. Okay. If the heaviest 2, I can really see why this is good for heaps. This is bigger than that one, right? So if this is bigger than that one, this will go away and that becomes 1, and we take the heaviest 2, which is 2, and then heaviest 2 is 2 and 1. 1 and 1 equals to 0. So this output is 1. What? Let's see. So if we take out 2 heaviest, right? Two, 7, 4, 1, 8, 4. So 8 and 7 first. If the stone of the weight x is destroyed, the stone of the weight y. Suppose the heaviest 2 stones have weights x and y, with x less than equals to y. So x has to be less than y. Okay. So 8 minus 7 is 1. 2 minus 4 is 2. Right? 2 minus 1 is 1. 1 minus, if it's equal, then it should be 0. Let's see. Yep. Oh, there's an extra 1 that I didn't see. I see it. And then boom, boom, and then 0. Okay. Why should we use heaps for this? Because if this is a max heap, wow. If it's a max heap, it's going to be 8 at the top. And we have 2 children, which is 7 and 4. And then we have 2 and 1 and 1. And wow. Heap is annoying, number 1, because I don't know it. Because right now, what is the right way to do heaps? Is this one right here, which is 4 and 7, and then 1 and 2. Oh no, 1 and 1 and 1, like this. So we can always take like that, becomes 1, and then because this is empty, this one goes up. So I'm gonna have 1. Oh, where's the 2? Oh, this is 2, bro. So this is 2. So I'm gonna have 2, 4, 1, 1, 1, because this is swap. I'm gonna have 4, 1, 1, 1, 1. What? Oh, 2 right here. And then take 2. This is a 0, and just go up. Take that 2. Boom. 1. This is gone. And then take that 2. Boom, boom. 1, 1, 1. I see that. I see it. But then how do I implement it, right? So I feel like we need to create heaps, add them up, so we have an array, right? So why don't we just start? This is gonna be heaps, for example, and then I'm gonna have, this is nums or stones. This the array equals to that, and then this stones equals to stones, and then counts. Oh no. Oh, okay. Like this. So heaps that prototype that add. If we do this add with the value, or we need a swap. And we can't do that while we're creating a method for the class. While we constructing the class, we can't do ES6 arrow function, so we have to do this. I still don't really understand like why we use heaps for that. I don't get it actually. Like, why do we want to use heaps? Because right here, my explanation is not clean. You know what I mean? Like, this is not pretty. It's not pretty. First, like, you have to add the stones into the heaps. Okay, so let me learn something here today. It is not the best solution to this problem, but I came. That's what he came up with. This is one thing is of working in front of stones array, and this is shift over when you call try working at the end. Using pub is faster than shift. Insert the array every time. You could insert a new value in the right position with the help of binary search. Okay. So simple priority queue. So we're seeing it happen over and over again. So max priority queue here is being used, which is a queue. We enqueue the stones and dequeue blah blah blah. Yeah, this is very simple, but how is this solution in Java? Yeah, actually there is priority queue. There is public class on a priority queue based on priority heap. The elements of the priority queue are ordered according to their natural ordering or by a comparator provided at queue construction time, depending on which constructor is used. A priority queue does not permit null elements. A priority queue relying on natural ordering also does not permit insertion or whatever. Okay, so JavaScript, the JavaScript code has MaxPriorityQueue. I see. I think like in Leetcode, there's a library that's already inserted here, which is the JavaScript data structures priority queue. I'm not sure if in an interview that they would actually accept this solution, but if it is, so what you do is first new max priority queue. So we have that queue for stones, queue.enqueue stones. I'm curious if this is already sorted because we're putting it into the queue. Well, queue.size is greater than 1. You take that. Okay. Max priority queue for stone of stones queue.enqueue stone. And then while queue.size greater than 1, we take queue, dequeue the element, and then second was dequeue the element. This is like popping, and then you're storing it into the variables. And then if first is not equals to second, queue.enqueue first minus second. What if it's a minus? What if it's what if it's a negative number, right? That was my question. But anyway, return queue.size equals to 0 is 0, otherwise queue.front element. If this is all it is with queue, this is actually pretty easy. This is actually pretty easy. Yeah, because it's built in. You don't even need to do anything with the data structures. That's why it's easy. Because right now it's just gonna be lined up, and it's sorted. First element, second element, right? And then you take the first and the second, and then you run the condition here and check. But this is already gone. And if there is, and queue starts from here. And queue starts from behind. Okay. Let's try it again. Let queue equals to new max priority queue. This. And then for let stone of stones, I want to do queue.enqueue stone. While queue.length greater than 1. We want to take that first equals to queue dot dequeue the element, and then let's second equals to queue dot dequeue the element, and then if first is not equals to second, I want to do queue.enqueue first minus second, and then return if queue.length equals to 0. I want to return 0. Otherwise, I want to return queue dot front element. Of course, I already know something is wrong. Why is it? Where is it that I'm... It's not queue.length, so it's queue.size. But was that it? Maybe. If that was it, that's pretty good. I want to see. I want to see queue. So it's a max priority queue. It's max heap. And you could do a min priority queue as well. I would say this is cheating, but I don't know. Is this cheating? If you're an interviewer, would you prefer me coming up with the solution? Obviously, huh? Because I think that was pretty easy. That was too easy. That's actually a good question. Should I ask? Who should I ask? Okay. Do you know if interviewer would accept the solution? That's what I want to know, because what's the point of lead coding if they don't accept this? Interesting one. But also, okay, if I want to solve questions using that, right? Because the hard part from heaps or heapifying it, swapping things, doing your check when you're adding, popping it, removing it, between the tree nodes. That's why it's so hard. So if there is this thing that we can use, it's kind of like cheating, in my opinion. But anyway, you're given an M. Okay, the K weakest rows in a matrix. The K weakest rows in a matrix. So if I'm thinking about matrix, I'm thinking about 2D array, and I want to find the weakest row. Column is gonna be that, row is gonna be there. So you're given M by N binary matrix of ones and zeros. The soldiers are positioned in the front of the civilians, that is the ones put to the left on each. Excuse me. A row is weaker than row J if one of the following is true. The number of soldiers in row I is less than the number of soldiers in row J. Both rows have the same number of soldiers and I less than J. Return the indices of the weakest rows in the matrix ordered from the weakest to strongest. If this is the case, I have 2, I have 4, I have 1, I have 2, I have 5. The 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1, 2. 0, 1 and we're looking for the k weakest rows, and k is 3, so the third weakest, the first weakest, second weakest, and then third weakest. But why is it 2, 0, and 3? 2, 0, and 3. So you go first, do that, did that, did that. So what do you think? What do you think? What do you think? So okay, weakest. If weakest, then what I want to do is let min heaps equals to new minimum priority heap, like this. And then for let I in map, but this is not only I want to do I dot reduce at each that row in mat. That row of mat. I'm gonna do let sum equals to row dot. I can do this filter of the ones and then that length. And then once I know that, I want to do min heaps dot do sum, and then because I know it's asking for k equals 3, 0, 1, 2, so it's gonna be turn min heaps k minus 1. Runtime error because this is what I don't know. Min heaps, min priority what? Q. Not heaps. It's gonna be Q. Oh. Pacifica. Oh my god. Dexter and Ernie. So nice. Wow. It's so nice. This is little baby. Little baby. Oh my god, little baby. Okay. I got distracted. Did I pass it? Did I pass that thing? What? In heaps. NQ, not Q. NQ of the sum. And define Y. So let's see. Console.log sum. So we got 2, 4, 1, 2, 5. Console.log. Okay, I think min heaps you can't access that by using the index, cause see that? How to I need to know the library, right? The minimum party queue JavaScript library. So this also, never in my life I got any problem using heaps actually. So just saying, how can I access the queue or the heaps? MaxPriorityQueue. MPQ.DQ 543. So we got push, we got front, we got back. Size to array. So we can make it into that to array. What? So I can't access that per index. Oh Lord, oh Lord. So we got priority 1, priority 2, priority 4, priority 5. the indices. Let row of mat sum equals to filter this row. Ay, ay, ay. What the heck? Try using heap. Oh my goodness. What the heck? Oh, oh my god. Wow. Yeah. JavaScript. JavaScript. Heap library. What is this? Heap. Oh my god. So new heap can peek but can pop. But then this can also for let I equals 0 and less than a minus 1 minus k I plus plus. I just want to do min heaps of I res stop push. And then console.log res. On the fun. Min heaps. I cannot do min heaps. So I can do min heaps dot dequeue dot element. Actually what I need to push is the index. We actually need the indices, not the sum. For each row of the mat. Sum is this. What can I do here? Yeah. No way. Okay, sum. Oh my god, bro. My head is about to explode. So I'm in heaps that in queue sum, but the problem is I need to know the index. So once I know this, number 2, pass in. I cannot do that. What do I do? Shit. I actually want to use the heaps, minimum heaps. Min. I don't think there's sorting. This is only Python solution for the minimum heaps. Oh my goodness. So tough. So tough. Like heaps is no joke. So first queue, MinPriorityQueue, compare A and B, B.soldiers, return 1. Mat that for each, let soldiers equals to 0, for let I, soldiers place equals 1, queue, soldiers in the index now. So you could do this, soldiers and then the index. So why can't I do that earlier? So I'm saying I'm in heaps, not in queue. I wanted to do this now. And then the index, and then you give me an error. But numeric priority or a constructor. Soldiers equals to what? So that reduce in B A plus B. Let's see if this one can work. And Q expects a numeric priority or a construct callback that returns a number. So is this not a number? Console log sum equals to 2. What is this type of? Should be a number. So if this is a number, what are you talking about? And Q expects a numeric priority or constructor callback that returns a number, because right now index is just index. So I think this is what's missing. In the minimum priority queue, I need this. Okay, I need to change a couple of items here. Soldiers, not soldiers. There's gonna be some. Index is minhips.dq. Before I do that, what is this index? Minhips.nq sum of I. So we got sum. Sum 1, sum 2, sum 2. With I equals to 4. So it's going to be 3, 2, 4. 3, 1, 4. So if index.I is going to be those numbers. Okay, so it's going to be index.I minus 1. I think that's it. I'm getting it, but it's just weird that I have to do all this stuff. It is weird now, but it's not gonna be weird later. So this is a constructor. If A and B, if B sum less than A sum, return 1. If A sum equals to B sum and A, return 1. Otherwise, return -1. I don't know this compare function actually, honestly. Honestly, I don't. But I kind of get the problem now. That's what happened when we're just cracking this, right? So at least I'm a little bit better than yesterday. I will try to do a couple more tomorrow. So today I think I did 2 of the max or the heaps problem. And we'll try to do a couple more tomorrow. Get better. But that's about it today. All right, see you tomorrow.